these activities. Why we need to do the sequencing? Because certain activities may depend on some other activities. For example, if you want to do testing, the development should happen. Until unless the things are developed, you can't do the testing, right? So if you want to cast the roof, you should have 4 pillars. If their pillars are not there, you will not be able to cast the floor, cast the roof. So this kind of dependencies are there of one activity on another. Therefore, it is important that we sequence them correctly. So by sequencing them correctly, what happens? But when we reach to a activity, all the activities on which it depends, it's already happened. So we don't stop there waiting for something to happen and then move. So such a situation does not arise by establishing sequencing. By sequencing, you will get certain this kind of network diagram. We call it network diagram. What it says, E will happen after D, B will happen after D and A. So what is A, B, C, D? A, B, C, D, E, F, G are activities. And arrow shows dependencies. So B can only start when D and A are finished. F can start when E and B are completed. C can start when B is completed. This method is called precedence diagramming method. Why it is called precedence diagramming method? Because we identify predecessor of each and every activity. So we identify who is the predecessor of F, it is E and B. Who is the predecessor of B, it is D and A. Who is the predecessor of C, it is B. And then we connect them. This method is also called activity on node. There was another method or there where we called activity on arrow, where we are used to show activity on arrow, and node was actually the juncture. But that method or that methodology is now obsolete. So all the network diagram you will find is in this one, activity on node. If you identify their I will say their duration also, so you can identify a critical path. Now, how you reach to this network diagram? By establishing relationship. Now, how do you establish relationship? It is here it is. There are overall 4 types of dependencies or 4 types of relationship. The first is called finish to start. What is finish to start? Predecessor finishes, successor will start. Right? So if it is A, it is B. B will start when A will finish. B will start when A will finish. In the second case, B can start as soon as A starts. B can start as soon as A starts. B cannot start before A. Right? We don't say it A and B are parallel. They are in parallel. But start of B depends upon start of A. If A does not start, B does not start. B can start later, but not earlier. Similarly, in the case of finish to finish, unless A finishes, B does not finish.
So on this start to start, A can start even if B has not started? Like B cannot start unless A has not started, right? On the start to start?
Yes, unless A start, B cannot start.
So, but A can start even if B has not started?
Yeah, A can start. A does not have any dependency. B is dependent. A is not dependent.
Okay.
A may be dependent on something else, but that's not mentioned here.
Okay.
In this case, A is independent. Now, in the case of finish to finish, Once the same thing, once A finishes, then only B will finish. When such a situation there, we put up finish to finish. And last one is start to finish, just opposite of the first one. What was the first one? That as soon as A finishes, B can start. Or B will start when A finishes. In the case of last one, SF, the B is going on. B is currently in progress. It will finish when A will start. In the first case, finish of A triggers start of B. In the last case, the fourth case, start of A triggered the finish of B. Okay, let's try to understand them with example. Can you suggest any example of finish to start?
That should be simple. I hope people can interpret it well and talk about it. Finish to start is the most common
Test.
relationship we should put in.
Yeah. So testing can only start after we finish the development.
Okay.
So
That's
that is
true.
one example.
That's true.
And this is the most common
Yeah.
relationship you will see, more predominant relationship you will see in any schedule diagram, sequencing program. This is where the most common, around approximately 50% will fall in this bucket normally. Okay.
That's right.
So
almost
I
70,
hope people
80,
have,
90% finish to start actually used.
so hope people have understood. So see, the key here is you have to look at it from the perspective. Which perspective is what is important? When I say finish to start, predecessor, successor. So the key here is to understand the meaning of predecessor and successor. From where do you stand and where do you look at? That is important. People tend to get confused because they shift their position, their view. It's like saying grass is greener on the other side always. That is the same logic here also. If you shift your position, the view will change. So, or if you look at your mirror, the view will change. So that is the problem. Don't change it. Be clear about your position, where you are. Then you will interpret this correctly, how this works.
Any example for start to start?
Start to start. Any examples? Okay, let me try here. Seema picked up a good example saying that testing can start only after development is done or the product is ready. That is the meaning. In software, the code is ready. In other cases, the product has to be ready only then it goes through testing. So let me think about it a step differently. One step ahead here is, you mean testing. So what do you want to test? There will be test cases or use cases written. Now, when do I start writing those use cases? Only when the development can be. So that is where the flagging of starts. So you start writing test cases before the development begins is the point, or before the contract begins, let's say. When do you start your work? Only after the contract begins. So start to start kind of thing. There may be a lot of other paperwork to be done and all that thing. Very often you say, oh, the major commitment is there. There is an email approval done. Let's start doing the work. The other paperwork will get done. The legal formalities will get done. We are confident those gets will be completed. The loose ends will be tied up, but you can start your work. Vivek, is that a good example or you can validate it?
Let me put up another example so that it will be even more clear. Suppose you want to construct a room. What do? You put up the brickwork and then plaster. Brickwork and then plaster. Brickwork and then plaster. brickwork and plaster. As such, if you see, you need to do first brickwork and then plaster. So let's consider that it takes 2 days to complete the brickwork of one wall and 1 day for plaster. Okay. So if one side of wall, if I want to do 2 days, it takes for brickwork and 1 day for plaster. If I consider that first I will do brickwork and then plaster, then what will happen? It will be in first brickwork and then plaster. So this will be 8 days and this will be 4 days. So overall it will take 12 days. But now look at it. Is it necessary that all 4 wall brickwork completes only then I start the plaster? Can't I
No.
start the plaster once one wall brickwork is over? When
Yes.
this
Yes.
brickwork is over, I can start the plaster when the brickwork of this is happening, right?
Yes.
And so on. So in this case, what will happen? I can start my plaster once the first wall brickwork is complete. So what will I do in this case?
Brickwork of first wall.
Then
We can start brickwork of other walls, and as soon as at the same time we can plaster on the first wall.
yes. So as soon as the first wall brickwork is complete, I can start the plaster. Okay. Let me do one thing. I think 1 minute. Give me a minute. Okay, let me do this here. Right? 8 days, 4 days, total 12 days. Right? Now, it should be something like that. 1 wall, 2 wall, and 3rd wall. And I can start the thing here. Right? So I can put start to start. But if I do start to start, it should start from here. But I want to start it from here. So what I say is start to start plus 2 days. Okay. So plus 2 days means with a start to start with a 2 days of lag, means after 2 days. So what will happen? It will plaster take only 1 day, right? So I will plaster will take, but the second brickwork is not ready. So the person will sit idle here. Then 1 day, then sitting idle, then 1 day, then sitting idle, and then 1 day, right? But what will happen? This whole time will reduce to 9 days, right? So this is how we can set SS plus 2 days. So we call it, this is called lag. This is called lag. So we have delayed the successor, though it is SS, start to start, but we delay the successor by 2 days. Okay. Now, what about these inefficiencies? This person is either have to sit idle for one day, or have to switch some other work which is also inefficient. Probably we can do this in another manner. Let's try finish to finish. So I have this 1 day, 2 days, 2 days, right? So this will be finished here, and okay. And then I will say finish to finish. That means when I say finish to finish, how much time, how much lag should I give? Basically of 1 day. Why? Because after finishing last wall, I need only 1 day to do the plaster of the last one. So I did like this. Finish to finish plus 1 day. And then I count 1 day, 1 day, 1 day, and here it is 1 day. Right? Now, when it is starting after 2, 2 and 1, 5 days. It was starting after 3 days, 2 days. Now it is starting after 5 days. These 3 days of inefficiency is taken away. The person can start the work here and complete the work at the same time. It's still 9 days, but this thing have been removed. Now, this is a circumstances in which FF plus 1 day is more efficient than SS plus 2 days. In some other circumstances, SS plus 2 days may be more efficient than FF plus 1 day. So the whole thing is that the same situation we can schedule in 3 different ways. In first way, it is taking longer time. In the second way, it is taking lesser time, but the resource allocation is not very, I say, efficient. In the third, our resource allocation also become very efficient and taking the lesser time. Right? Is it clear that how these SS and FF working? Now this is called lag. Now, similar to lag, there is a lead also. Now, I will come back to here. I say, why not I put it like this? 1 day, 1 day, 2 days, 2 days, 2 days. And I say it has to start here, right? I can start it here. Something like this. This is also 9 days. And this is similar to this. What I will say, FS minus 3 days. Now achieve the same thing with FS minus 3 days. Minus 3 days called lead. When we advance the successor, it will become lead. When we delay the successor, we call it lag. Why do we do so? Because of making project more efficient, reflecting ground realities, making project plan, project schedule more realistic. Right? Let's go back. What will happen now? What about the last one? Any example for last one? Have you seen some task is starting, triggering the finish of other task? Any example? Any guesses?
The concept is clear, but I don't remember if, of any example. Most of the examples that we have is finish to start. No?
Okay. Have you seen those shift duties?
Yeah,
You have shift duties. Suppose,
we do.
yeah, suppose first shift is coming to an end, but the second shift person does not come. The first shift person can go.
He can't until the other shift comes, yeah? And then
In most of the cases, because things are not be left unattended, the first shift person wait for the second person to come. For example, your society or office security guards, until unless the next security guard comes, the first security guards cannot go. And if second shift security guard come earlier, probably the first shift security guard is free to go early also, because there is a person at the gate. So if you see what is happening here, the start of second shift triggering the finish of the first shift. The end of first shift depends upon the start of the second shift. Does that make sense?
yeah, very clear, yes.
But in project, it is not very commonly used. In fact, it is rarely used. Some dependencies are mandatory dependencies, like you need 4 pillars before you cast the slab. Mandatory dependency. You have to develop the things before you test it. Mandatory development. But there are discretionary dependencies. For example, you need 4 columns to cast the slab. But what about 4 columns? You can do them one after one. You can do two at a time, or you can do all 4 at a time. Your discretion. You can plan the way you want. So these are called discretionary dependencies. When we optimize the schedule, we will come to this later. These are the discretionary dependencies, are the dependencies on which we actually relook and try to adjust the things, because it is as per our decision, not mandatory. So we can reshuffle the things, can go a little adjustment here and there, and can optimize the schedule. We'll come to this later. You can see the lead and lag. So lead, you advance the successor, lag when you delay the successor. There are various practical situations in which you have to do it. You create a schedule, a network diagram, and something like that. So here you have added SS plus 1, FS plus 5, FS minus 2. What does it mean? That E will start when D finishes and 1 day after B starts. So E will start when 1 day after B starts and D finishes. G will start 2 days after F finishes. C will start after 5 days after B finishes. This way you get the network diagram, and if you calculate the total duration of the project, you can calculate the total duration of the project and can identify the critical path. We'll come to this little later. Now, to come to the critical path, we have put the sequencing, but you see There are numbers mentioned in the node. What they are? They are the duration of that activity. E7, F10, H5, they are duration of the activities. How we have arrived on that? How much time, how much duration an activity will take? How we arrive on it? That is the point. That is the next point.